We have gazed at the stars for years, fantasizing about visiting and even living on other planets. However, it is no longer just science fiction. Space colonization is becoming a reality as technology advances. We may see humans living and working in space thanks to scientific advances. These videos show some of the top space colonization plans currently being developed. What are your thoughts on these plans? Are you excited about the prospect of humans living in space, or do you believe it is too dangerous? Keep watching until the end to find out. Since the 20th century space race, the motivation for human and individual nation investment in space exploration has shifted dramatically. The competition between the Soviet Union and the United States to achieve the first spaceflight drove late-century space exploration. Now, both the private sector and national governments are investing in space exploration once more. This time, however, they are motivated by protecting human life from catastrophic events and leveraging space resources. Before we continue, please give this video a thumbs up and subscribe to this channel for more content and click the bell button. Have you done so already? Let us get this party going. What is space colonization? Space colonization, also known as space settlement, space humanization, or space habitation, refers to permanent, autonomous, self-sufficient human habitation in locations other than Earth. It's a central theme in science fiction and a long-term goal of several national space programs. Many people envision space colonies on Mars or the Moon, but some argue that the first colonies will be in orbit. Several design teams at NASA and elsewhere have looked into the feasibility of orbital colonies. Near-Earth asteroids, that solar energy is readily available in large quantities, and no new scientific breakthroughs are required. However, considerable engineering would be required. The evolution of space colonization. The concept of space colonization dates back to ancient myths and legends. However, the first account of an actual space colony appeared in 1869 when Edward Everett Hale's novel, Brick Moon, described how a colony in space occurred accidentally, planned to colonize outer space. It has been argued that space colonization ensures human civilization's survival in the event of a planetary disaster. Colonizing other planets allows humans to disperse, increasing their further chances of survival in a planetary disaster. Furthermore, the availability of additional resources that can be mined from space has the potential to significantly expand human capabilities and benefit society. Using these resources and moving high-polluting industries to space could reduce emissions on Earth and eventually lead to the discovery of cleaner energy sources. The primary impediments to space colonization are technological and economic constraints. Many private companies are working to improve the efficiency of space travel to lower the overall cost of space travel and, thus, space colonization. With the release of the Falcon 9, a reusable rocket, SpaceX has emerged as a dominant leader in the push for efficient exploration. NASA's Artemis program aims to land a second man and the first woman on the Moon by 2024, establishing sustainable space travel by 2028. The Artemis program is a step toward NASA's ultimate goal of landing on Mars. Number 1. Strong propulsion systems to get us there and back faster. Astronauts heading to Mars in space will travel approximately 140 million miles into deep space. Propulsion advancements are critical to reaching our destination as quickly and safely as possible. It is too early to say which propulsion system will transport astronauts to Mars, but we know it must be nuclear capable to reduce travel time. NASA is working on various options, including nuclear, electric, and thermal propulsion. Both use nuclear fission, but they are very different. A nuclear electric rocket is more efficient, but it produces less thrust. On the other hand, nuclear thermal propulsion has significantly more oomph. Regardless of which system is chosen, the fundamentals of nuclear propulsion will reduce the crew's time away from Earth. To reduce the risk of the first human mission to Mars, the agency and its partners are developing, testing, and maturing critical components of various propulsion technologies. Number 2. Inflatable Heat Shield for astronauts landing on other planets. The largest rover we have landed on Mars is roughly the size of a car, and sending humans there will necessitate a much larger spacecraft. Thanks to new technologies, heavier spacecraft can enter the Martian atmosphere, approach the surface, and land close to where astronauts want to explore. NASA is developing an inflatable heat shield, which will take up less space in a rocket than a rigid one. The technology can land spacecraft on any planet with an atmosphere. It would expand and inflate before entering the Martian atmosphere to safely land cargo and astronauts. the technology still needs to be quite ready for Mars. An upcoming flight test of a 6-meter, 20-foot diameter prototype will show how the aeroshell performs as it enters the Earth's atmosphere. The test will demonstrate that it can withstand the intense heat of Mars's entry. Number 3. Advanced Martian spacesuits. Spacesuits are astronaut-specific spacecraft. NASA's latest spacesuit is so advanced that its modular design allows it to evolve anywhere in space. NASA's next-generation spacesuits, known as the Exploration Extravehicular Mobility Unit, or XEMU, will be worn by the first woman and man on the Moon. The spacesuits prioritize crew safety while allowing Artemis-generation moonwalkers to move more naturally and perform tasks that were impossible during the Apollo missions. Future improvements to address the differences on Mars include technology for life support functionality in the carbon dioxide-rich atmosphere and modified outer garments to keep astronauts warm during the Martian winter and prevent overheating during the summer season. Number 4. Uninterrupted Power. Astronauts will require a reliable power supply to explore Mars, just as we use electricity to charge our devices on Earth. The system must be lightweight and capable of operating regardless of its location or the weather on Mars. Mars, like Earth, has a day and night cycle and periodic dust storms that can last months, making nuclear fission power a more reliable option than solar power. NASA has already tested the technology on Earth, demonstrating that it is safe, efficient, and abundant enough to support long-duration surface missions. NASA intends to test and deploy the fission power system on the Moon first, followed by Mars. Number 5. Using laser communications to send more data home. Human missions to Mars could use lasers to communicate with Earth. A laser communication system on Mars could transmit massive amounts of real-time data and information, including high-definition images and video feeds. With current radio systems, sending a map of Mars to Earth could take 9 years, but with laser communications, it could take as little as 9 weeks. The technology would also allow us to communicate with astronauts and see and hear more about their adventures on Mars. In 2013, NASA demonstrated the feasibility of laser communications from the Moon. The agency's next demonstration will run through various operational scenarios, perfect the pointing system, and address low Earth orbit technology challenges such as clouds and other communications disruptions. NASA is developing small systems for human spaceflight, including those for the International Space Station and the first crewed Artemis mission. Another laser communications payload will travel to deep space to learn more about what it takes to use the same technology millions of miles from Earth. The video for today has concluded. Remember to thumbs up this video and subscribe to the channel to see more content. Remember to click the bell icon to be notified when new videos are posted. I will say goodbye now and hope to see you in the upcoming video.